Welcome to project phase 1 demo video for distributed database systems, CSE512. Our group name is MH12 and we are a group of 3. The group members are Saurabh Abhale, myself, Yash Belorkar and Tanmay Manolkar. Moving ahead with the demo video, these are the tasks we are going to cover in this video. First of all, let's start with the prerequisites, what all needed to implement this distributed architecture system. We have taken a master PC, which is the host operating system, and there are two virtual machines which are installed Ubuntu as well, and the host PC is also installed Ubuntu. This is the master PC IP. This is the first virtual machine and this is the second virtual machine. The software versions of Hadoop and Spark used are stated over here, that is 3.00 and 2.2.1 respectively. Moving ahead with this demo, the basis of this demo is establishment of passwordless SSH communication between all the nodes, and not only just passwordless communication but as well bi-directional communication. Hence we followed these steps to establish the bi-directional passwordless communication between any two nodes. So first of all, we generate the public key and the private key using keygen, then copy the public key of the host machine to the remote machine using SSH copy ID command. Then we log in using SSH by providing the password, and then we add the public key of the host to the remote's authorized key file. This file ensures that whenever there is a login request, SSH login request from another user which is registered in authorized keys file, no password is required. This all communication has been implemented bi-directional between the master node and the slave 1 node, as well as the second slave and the master node. The Hadoop configurations we have used are as follows. First of all, we have on the master we have edited the host files to map these IP addresses to respective masters and slaves. Apart from that, we have edited each of the slaves to map the master IP to the keyword master. Apart from that, we have edited the configuration files on the on all the three uh, nodes, that is the master and the slave nodes. Some configurations are edited on all the machines, some are edited only on the master machines. The replication value in this configuration indicates the number of nodes which are communicating with each other. Then on the master node, we first format the name node so that there is no data on the name node. Then ideally we push the files, the dataset files, CSV files, which are given as part of the assignment question, to SDFS on the master node, and then we start the Hadoop instance on the master node. Similarly, these configurations are done on the other slave 2 nodes as well, but as there is no name node on the slave nodes, there is no need for pushing the dataset files on the slave nodes. Spark configuration is as follows on both the slave nodes as well as the master node. First of all, we need to set some variable Spark master ID in the Spark configuration file, and then start the Spark master instance. The slave instances of Spark are connected using this command to the master node, and once we establish that the connection has been successful, we can see on the UI which has been provided by Spark on the master node that there are two alive nodes. Apart from that, we run to run the Spark shell along with some jar files to execute GeoSpark APIs. We use this command. Now, as we move forward, let me demonstrate each and every part of this presentation, how it has been executed. First, let us demonstrate each passwordless SSH from the master to the slave 1 node, from slave 1 to back to master node, and same with the slave 2. First, let's SSH from master node to slave 1. As you can see, I am executing the command. As you can see, there is no password required for SSH to SSH login. Now from the slave 1 node, I am rolling or logging back to the master node. You can see there was no password required for logging in. I'm just closing all the SSH connections. Now you can see there was bidirectional communication between the master node and the slave 1 node. Similarly, we can I'll demonstrate how bidirectional SSH passwordless communication takes place with second slave. I have logged into the slave 2 with no password required. From the slave 2, I am logging back to my master node, and again there's no password required. I'm just closing all the SSH connections. Moving ahead, the Hadoop cluster is as such that the name node and a data node are running on the master and there are two data nodes independently running on each of the slave nodes. This is how we have formed the cluster. To see how the cluster is running, I'll demonstrate it using this interface provided by Hadoop. As you can see, there are three live nodes in the cluster, and you can also see that this is the master node running over here. I'll just show you the file system on which we have loaded the dataset files, which are further going to be processed using Spark and Scala. Moving ahead to showcasing Spark clusters. This is the portal where you can see all the Spark clusters. In the Spark cluster, you can see there are two alive workers working, which are the two VM instances, and this is the master node IP, which URL which you can see. Now let's move ahead to execute some code snippets on the Spark shell. So I'm executing this command. As you can see, now I'm going to execute the Spark shell command from the bin directory of the Spark, and simultaneously I'm going to load the GeoSpark jars in the Spark shell to execute all the code snippets. I'm just taking one code snippets. Here the Spark context is not required. As you can see, when the Spark loads, Spark context SC is already available. Now I'm just pasting all the commands one by one. This was the first part of the code snippet was to set the configuration for the application. Now I'm going to run the range query, which is without index. As you can see, the result size for range query without index comes to be 445. Now I'll run a range query with index. As you can see, also the result size for range query with index also comes to be 445. Now moving ahead, I'll run for knn without index and then with index simultaneously. You can see that result size for KNN without index comes to be 5. Similarly, KNN with index, also the result size for KNN with index comes to be 5, as you can see. And now I am performing spatial join without index. I am copy pasting the code snippet in the Scala shell. This will take some time to execute. As you can see, the result size for join query without index comes to be 25743. Now I'll run the join query, uh, spatial join query with index. I'm running spatial join without index. This will take some time. As you can see, the result size comes to be, now I'm running the spatial query with index. You'll be able to see that the value comes same as the without index. This will also take some time. Similarly, all the distance join query with and without index can be run as similarly this can be executed, but this takes too much of time to run. Hence I am concluding my demo video for the phase 1 project for the group MH12. Thank you for joining with us.